Welcome to today's talk. What I'll do is do the talk and then have questions afterwards. So if you've got questions, put it in the chat section. So without further ado, I'll hand over to Bruno.
Hi, thank you, Sam. So my name is Bruno. I'm the CTO at Material. We are expert in, well, we try to be expert in cybersecurity, specifically in application security. I'm a developer. I started in 1988, so a few years ago. I've been introduced to the marvelous world of extreme programming in 2000, and I also been awarded the Java champion title. So I'm obviously biased in Java. Sorry about that, because I also co-founded a Java user group in my country, Italy. I'm from Italy, and yeah, recently I've embarked in this experience of startup, which is really challenging. You really need to have to be strong to go through the hurdles, you know, because I have some experience in this field, and I decided to share with you some information that you might find useful. We're going to talk about open source components and how they stay within the system we build and how it can be sometimes harmful. And then we will have also a little bit of demo of a hack live, so to show you how simple could be to exercise a vulnerable component. So do I want to wait a little bit more, see if any more people are coming? I can keep talking about rubbish, but yeah, I mean, the thing about security is that is a very large field. So here you will see a very narrow section of it. Although this section is very narrow, is also still very important because there is a lot going on. Things are changing very quickly, and you want to be sure that you stay on top of things. And you know, open source components have been there since the beginning of time. I mean, not really like that, but since a long time. We recently added support from Perl, and incredibly, for me at least, because Perl has a rich ecosystem of open source components and a very complicated distributed system to handle them. And so they have been available for a long time, and it's incredible the impact that they might have on your software. So that's the reason why it's important to know about them and know the risk associated to them. So as I was saying today, we will review first some past hacks. So have a look at famous hacks that happened in the past. We will discuss what is a vulnerability and why do we use open source components if they're so risky. We will show you how to inject and execute code into a remote server. Please don't do that. Well, do it on your servers. You have everything you need. You will have you can clone the project from GitHub and do it yourself in a selected environment, a restricted environment. And then we can have some conclusion, then Q&A. All right. So timer here. Right. Some past hacks. I will start from 2016 from San Francisco, because this was the start of a series of hacks repeated using the same mechanism. So basically what happens is that the users went to take the train, the Metropolitan train, and they find this nice window showing that the system was encrypted, blah, 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 and, you know, enter the key, something some of you, hopefully not many of you, are familiar with. So the system was hacked and the data were encrypted and was encrypted, and, you know, and that's where they ended up. San Francisco, they had 2,112 systems impacted. The good thing is that you had a weekend of free rides. That's good. they say that we're not hacked from the outside, but this was rapidly discussed. And the problem, the hackers went from the outside, so they basically exploited an object serialization issue in Apache Commons collections. It's a library that it's used all over the web. Now we'll have several versions of it. More tech savvy of you may be using Guava now, some modern things, but Commons collection is still all over the place. And they basically hack the binary traffic between different application servers, and they were able to inject code in it. So then the amazing thing about that is that this event triggered Operation Rosebud. So basically, Google staffed a team of 50 employees to go on GitHub and patch every single place where this open source project was used. So that was an amazing. You can read if you search Operation Rosebud on Google, there are some interesting tales about that. But just to focus a little on the object deserialization, because this is what we're going to use later to do the hack. So whenever two systems, so as you probably most of you know, whenever two systems are talking together, they're using an intermediate language. So they maybe internally they have a binary representation of the data, but then when the data is sent over the wire, it's translated in a more in a more open format. That can be JSON, XML, JSON. There are different formats, but the trick is, if I want to talk to you, you're another server, and I want to talk to you, I have to use an intermediate language. Like now, I'm speaking to you in English and not in Italian. If I were to speak to you in Italian, you wouldn't be able to understand. And maybe the same on your side. There are people from other countries, and we're using English when we speak to each other. So in our mind, we kind of translate what we want to say from our native language to English. We send it over the wire, and then you receive it, you translate it back to your native language. This is how serialization and deserialization works. So we serialize from binary to open format, and we deserialize back from open format to binary. And the thing is, this process can be exploited, and this was happening inside this hack. But we come back to this later during the demo. So this is in Canada. The next year in Canada, the Canada Revenue Agency was hacked. This is the equivalent of HMRC, but in Canada. And they were hacked using the same exploit, exactly the same exploit 1 year later. But this exploit was different, because this exploit was exploiting another component, which some of you that have been working in Java for a bit of time may remember. This is Apache Strats2. It was a very common system, a very common framework to build web application. It came from the mix of Struts1 and WebWork, and was basically a system where you can have everything pre-prepared, build your own web application. You have things called actions that executes code. They have views, usually managed by GSPs, and it's a very powerful framework. It was very common, and to these days, a lot of customers still using it, because this exploit has been exploited recently also. So basically, the way this works is that you can basically send a request and inject in the request some stuff, and that the stuff is executed on the remote server. To be more precise, this happened also in Equifax. Again, 2017, this is the entire world suffered this. This is one of the biggest, Equifax is one of the 3 biggest credit rating agencies between US and UK. You are probably on Equifax, even if you don't know. I was. So what happened is that Equifax was hacked with the same Struts trick that was used to hack the Canada Revenue Agency. A crafted header sent over the wire or on an apparently innocuous HTTP connection. There were, of course, web application firewalls and normal firewalls, but Nobody was able to detect that because it looked like normal traffic. It's just HTTP, text over HTTP. What can happen? Well, the problem is that it did happen. So you may have received a letter telling you that you were hacked, blah, 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 like some of us did. But basically, customer names, social insurance numbers, birthdays, addresses, credit card, all of it, they were all scooped from the servers. Because the moment I'm able to execute code on your server, I will start extracting data from it. This is called exfiltration, a technical way, but basically I'm just gonna get everything is there. I'm gonna get it on my side and then sell it in the black market. The hack was admitted after 2 months. It's interesting to know that some shareholders managed to sell some shares before the hacks were announced. They eventually went to jail, some of them, not all of them. But that was interesting. You know, you may notice that pattern, like because whenever something, the recent hack of Facebook, for example, they're all announced on Friday. Why they do announce the hacks on Friday? Because on Friday, then the market is closed. So there is no way to sell and manage that. But of course, we have insider information. Hey, the settlement cost was 1.3 billions, but eventually it skyrocketed to, I don't know, 20, 30 because of the legal associated cost to it. So it was just amazing. It's just and GDPR wasn't there yet. So imagine with GDPR what would have happened. Now the same hack was repeating again and again and again. The Japanese Post, the County Revenue Agency already said, Aadhaar in India, the India Post, University of Delaware, the Payment Gateway GMO, Alaska Airlines, the same exploit again and again. Why? Because this, like every piece of software, can be automated. Every single piece of software can be automated. And even a hack can be automated. And they are automated. And usually the hacks are run using your toaster or your router, and not certainly somebody else, the hacker computer. So because they can be automated, they can be repeated again and again and again and again. And that's a problem, because now today I was reading, most of the hacks are coming from human error. That's true. But when you have a hack like that, and you can repeat it across the world, every single company, you will hit a lot of successes along the line. So that's the problem with these hacks. They can be repeated again and again and again. So this particular hack, just to look a little bit into it, because we are in a Java user group at some point. This is an issue in the multi-parser in Apache Strats2. The Jakarta multi-part parser is used also in other project, but here Struts2 has basically the ability to parse and execute OGNL, which is basically a language that you can use in JSP and in views in general to interact with objects directly. And the tricky thing is you can send an OGNL formatted piece of string inside a header, one of those 3 headers: content type, content disposition, content language header. What is going to happen is that the server will try to parse this header. It will fail, so far so good, but then it will also log it. At the moment that the log is executed, the OGNL is executed as well. So the OGNL is interpreted and executed. So sometimes these attacks are coming from places that you don't really think about, you don't really consider. They just happen, and you don't have any protection to it. The thing about this hack, and again, what happened in Equifax is that these hacks could have been prevented, because this CV was raised way before the Equifax attack, way before. So everybody was aware, and it could have been prevented if only there were some kind of, cybersecurity system looking at the components, open source components used by the application. Because remember, this is not your code. It's not the code that developers write. This is code that we pull from external sources. And it's usually very good code. Open source is great. You wouldn't be able to build anything really without open source. But the problem is you have to keep an eye on it.
Sorry about that. I'm not sure what's happened. I'll see if I can find a bit of a technical fault, so I'll just have a check. Hi, Bruno, you back now? Yes, all good.
Yeah. Yes. Apologies for the disruption, guys. I don't know what happened. Well, maybe I was hacked live. Who knows? Let me just get the presentation back, and I will resume sharing my screen. There we go. Okay, share screen, and here we go, share. All right. Okay, let's go back where we were before. We were like here. So yes, what I was going to say before is now that the same problem is now available in a different way. So in 2019, there was another hack using the same mechanism. So again, it was an OGNL powered attribute this time. So you can send an attribute over the request using OGNL, and this attribute may contain an OGNL text, and that text will be executed as OGNL. So that's another form of attack that is recently resurfaced for Struts. So going back to more recent things, 2018 British Airways. No, you may be familiar with this. Again, I was, I'm probably unlucky. I was hacked as well. So basically, this was due to another component. This time, a JavaScript component called Modernizer. Modernizer was hacked, and few lines of code were added to it, so that it would send the data of your customer, your data of your card, not only to British Airways, but also to another site. So everything looked nice, but when you click the button was triggering a piece of code in Modernizer that was sending the data to, well, where you don't want to that to go. This was also due to the fact that Modernizer was a 2012 edition. So that component was a 2012 version, and probably 6 years later, they probably should have updated it. Another one is Jet. So again, that was not declared. We can only rely on some surface scanning analysis that was done. What we can see, what we could see in the EasyJet hack, it was that we had two components responsible, possibly one jQuery and another Angular. So the problem with those two components, those are great frameworks. But if in 2020, using jQuery of 2014, and they're using Angular of 2015, then you may have a problem. So that's probably what happened. This we don't know. But again, the mantra is always the same: open source components which are not updated or are vulnerable. You would be surprised on how many do we have in the wild. So we have, like, on website, only 20% do not contain any vulnerable component. On cloud system, only around 40% do not contain vulnerable component. Many of them contain some vulnerable component. The only reason why they're not exploited so much is that that particular pathway that you want to use with the exploit is not available because the code is structured in a way that is not usable. But this is the situation now. This is based on surface scan that we do routinely with my company. So this is the problem. So when you have an application, the code that you carefully write is about 20% of it. The open source component is around 80%, and some of them may be vulnerable. So that's the largest attack surface available for hackers. It's just that you don't see it. It's just hidden inside, your manifest files or your binary folder, target folder, whatever you use. So they're just there. You don't know, but they are there. So what is a vulnerability exactly? You listen to me talking about vulnerabilities, what the heck it is. Well, is basically a weakness that was discovered in a system. So because open source components have been rebuilt, upgraded and updated again and again so frequently, they have a very fast life cycle. You know, bugs are fixed, but also vulnerabilities are fixed. And once somebody fixes a vulnerability, well, it may request to publish the problem to the CV, to the NIST database, for example, or to GitHub, to ANA or any of the other authorities. So, and then you get a CV like this one, no, which basically codify the vulnerability. And we have these big databases, the NIST is one of them, where all these vulnerabilities are managed. I mean, there are a lot of others, and NVD is the most important one, but personally, in our system, we ingest 26 different sources. So there's a lot of different sources. And then, of course, we can also look at the single repository to look at there is a vulnerability there. So the strategies are very different. Everyone is doing this job slightly differently. But yeah, the thing is, just in 2020, we had around 51 new vulnerabilities every day. And of course, this is across the board. This is not only about a single language or a single ecosystem, it's across the board. So this is why it's important to have a look at them. Somebody now might say, well, but then why do we use external components if they're so dangerous? So why we decide to take the risk? Well, first you want to build software fast, no? And you cannot write everything from scratch. Imagine building a house, no? I have this metaphor, building a house just with raw materials. And you have to build everything from scratch, bricks, windows, poles, everything. Why would you do that? No, you can definitely have things ready-made, no, and avoid every time rewriting everything. This is the same with software. You don't want to write everything from scratch. You don't have time because code is already available. So if I want to send an email, expose an API, connect to a database, I don't want to go from the excruciating exercise of building these things from scratch. I have it. No, again, in the house, I need a window. I buy a window. I'm not going to build it with glass and whatever. I don't know, wood, metal. I don't even know how windows built, but switches, all this stuff. I'm going to build them. I'm not going to build it myself. And also, sometimes you need state-of-the-art algorithms. So you may not have somebody that could create a crypto algorithm right under your desk or in the closet. So you may want to get a library that does that. All the library about AI and in general machine learning and everything about crypto, you cannot reinvent them. So you have to use something that's already there. So just to say this, there are really good reasons why you want to use open source components. Now, we're going to move to the demo now, and we're going to show you today how to exploit an old CVE, but still actual, because CVEs of the same packages are still happening, but I'm exploiting an old one. So this will allow me to basically inject Java code in a remote server and execute it. Oops, sorry. Let me go back, and then I have to start. I'm going to use Eclipse for this. Some of you will be amused. All right. So let me just put a little bit longer. There we go. And then we prepare. It was all prepared before, but unfortunately now I have to redo it from scratch. But it's not a problem. So what we have here, let me enlarge the font a bit. Okay. What we have here is a simple system. This is a server that exposes APIs to manage a product database. No, and this is really very simple. There's nothing awkward about it. So we have this product database, and we're supposed to APIs. One that allows us to list the products, another one that allows us to post a new product. That's pretty much it. So we can add the product and also list the product. This is very simplified, of course, so there's nothing complicated about that. As you can see, we're using Spark Java, which is a very simple framework to do. It's easier to do this way, to use a web application as APIs. We do have this section, these two APIs here. And then, when you receive the request, the product is deserialized by the request using object mapper, which is from Jackson Databind. No, it will deserialize the product, and then it will add the product to the database, and then return a 201 created, and returning back also the product as it was written. The list will just list all the products one after the other. The product database is a stupid.
Oh, sorry, is it okay to zoom in just a little bit, if that's okay on the screen? Is it possible?
Sorry, say again?
Is it possible to zoom in on the screen?
Yeah, that's right. I thought I did it. Let me just see if I can. For some reason now the zoom in doesn't work, which is really annoying. Give me a second. Yeah, somebody said if you had, it should be. Right. Unfortunately, my setup were all tits up when the system collapsed. So that's the main thing. Text font. No, this is not the text font. I don't remember where is it. Java editors text font. What if we do this? Yeah. All right. Better?
Yes, better. Thank you.
All right. Sorry about that.
Sorry.
So, because I have everything set up and then the system collapsed. So tough luck. And the product database is just a very simple, stupid object. So it's just a map that contains a product and a list and a map and a key, which is the name of the product, or a random key, and basically each product has this structure. So it has an ID, a name, and a description, and then a data object. This is the key. We have this object which contains different data. So usually you have some hierarchy here associated to it, but I didn't go to the complexity of it. I just put object. So this is the key where the injection comes from. Because when you have this, you can potentially put in this data field any object. So let's look at how this thing works. Zoom in a little bit here. All right, let me just check. I have to go into the directory of that. Here we go. All right. Okay. Let's launch the server. All right. So this is the server has started and is waiting for requests. So here I already prepared some curls. So I mean, I'm sure all of you know what curl is. Curl is just a tool to make a request using HTTP. So for example, I have this that basically does a curl request, right? And ask the API to return a list of products. So you can see here, curl HTTP localhost 8888/products. No, and then this is the server response, and this is the response that I received. So imagine that I'm not on the localhost, of course. Imagine I'm in Australia or in Russia. I don't know, to make it more real. I'm in Russia. The guy with the black screen is in Russia, and the server is in your in your Amazon in London. No? So the guy from Russia tried the API and see if it works. Oh, that's cool. I try again. Yeah, I can see that is how it works. And then what it does, this thing has other APIs, of course. It discovers this API to other product, and this will be the API. So this will add the product. So basically, it will create a new product named Melon, description real Melon. So you see, then during the post, you will send the data on the wire, which is basically a JSON message. It's nothing more complicated than a JSON message. So we send the JSON message, and the message is received, and you see the server says add. Okay, I received the Melon, and now I added the Melon to my list. In fact, if now we ask for the list again, we will receive a list containing also the Melon. Here we go. The Melon from Italy, you remember? Yeah, every fruit is from Italy. I don't believe in British fruit, unfortunately. I don't think it exists. So I think yes. Spain is also okay, yeah, but so everything is from Italy. So this looks all nice and dandy, right? But what's going to happen is that the hacker will send a malicious message. So what he will do, he will send a message which do not contain only JSON, but contains something else. So if I now run my exploit, I already prepared it. So you will see what happened here. Here we go. So what happened? The guy in Russia made this post sending this JSON to our servers in London. The request was not accepted. Something bad happened here. But what happened here is that, what is this coming from? This is basically the hacker executing remotely on your machine. So every time I run this, I execute this code. And you see the server is confused. So what's going on? I don't know what I'm serializing here. Oh my God, whatever. No, but it's too late because the system was already hacked. So of course my hack just prints a nice message. So that's pretty much what it does. I think I have it here in the export. So this is what my current hack does. No, it just print a nice message. But how does this thing work? So, but I can do anything here. I can send to a gist some of your users files, whatever, collect data from database, get information, variable, everything. So I can do everything. I'm executing as your user on your server. So how this works? So basically, this class exploit extends this org Apache Tisarang SLTC runtime. What is that? This is a particular. This is the vector, how we inject the virus. So this is basically a particular class, an abstract translate, which has a particular way to being deserialized. No? And when it gets deserialized in that particular way, my code is executed. And the code that I put here in the constructor of the class. And it's and how do I send this code to the server? So how this happen? How can I send Java code to the server? Well, the way I do it is by sending the code in the translate itself. This is how beautiful is it. So you see this long string is a little bit small, but this long string here, it is Java code, which has been translated, encoded using another vector, the template simple class. So you see, I'm sending an object with a name, a description, and in the data, I'm putting weird stuff. I'm putting this, I'm saying, oh, this is the class, and this is how, and this is the parameter of the class, and this is how it works. So what happens is that the system see a class, tries to instantiate it. The instantiation creates the translate loads the bytes in memory. The bytes are executed, and here we go. You have a hack. And if you want to experiment here in the same code base, you also have the encoder. So you can, it's very easy. So you pick up the class, no, and you encode it in base 64, and voila, you have whatever you want to add inside here. And then whatever you get from here, no, this thing, you put it into the JSON exploit, and then it would be executed on the server. So that's basically how this exploit works. So it is quite dangerous. If this code is available on GitHub, it's the presentation I will send over. So be aware of those things can happen. Going back to the presentation. So you probably asking, so well, what shall we do then? So you saw how easy it is to hack if we find the right route. It's not simple, but again, repeating, you find it. So what can we do? So first you have to be aware of the problem. Many people are not aware of this particular issue. They are not aware that most of the code they are using is basically code which is from open source components. So you have to integrate a software composition analysis tool, SCA, in your development process. And this can happen then automatically in CI. You can use GitHub Actions. You can do it manually by a developer. There's several ways to do it. The best thing is having inside automation. So in your CI/CD pipeline, add a software composition analysis tool, and they will tell you if you have any possible problems. And then you will have to look at those problems. You will have to look at them and decide, is it something that we want to fix? Or is it something that doesn't affect us? Because sometimes vulnerability do not affect you, and that's fine. That's okay. Preventing one of your questions that may come later is this one. So can I rely on GitHub to protect me? No. So GitHub is working since couple of years, building his own database of vulnerabilities and his own scanning abilities. They did a great job. They bought the Dependency, which do some of it, and now they're integrating with it. But the problem with GitHub is its database. The database of vulnerability of GitHub is very, very small. So you see here in green, the database of vulnerabilities of GitHub for .NET and Python. I don't know why I didn't pick up Java, my bad, but it's similar. Java, I think they have like 1,000, and normal databases, they are 8 times that. So in green, the GitHub databases. In yellow, the NVD database, the National Vulnerability Database, one of the gold standards for vulnerabilities. And then in red and blue, competitors, commercial options. You can guess what the blue is. The red is another big competitor in the same field. So there is a reason. What I'm saying here is there is a reason you want to have a commercial solution and not rely on GitHub at the moment. Because the database of GitHub is really, really small. It's available. You can have a look at it, github.com/advisory. You will set the database and see for yourself. There's zero coverage for Rust, Elixir, and Swift. I don't know if you're using any of those. I find Rust very nice, a very enticing language. So I think it would be more and more popular. But hey, you want to have something there. I have a blog article that explains this problem. You can also have the source of the hack. This is where it is on GitHub. And of course, you can get in touch with me. You can email me or on Twitter or any other channel, and I will be available to answer your question if you have any questions. This is something I'm passionate about. You may have noticed. I do have other hacks, but I don't want to disclose them all at once. So if you have any question, please shoot, and I will try to answer. I think there's some question on the chat. Do you want me to if you have any question, you can ask on the chat, I guess, right? Sorry, Barry. Sam, I called you Barry.
Yeah, that's right. So there's no questions in the chat at the moment, but does anybody have any questions? Feel free to unmute or put in the chat box.
Yeah, apologies again for the disruption. I don't know what happened. Maybe I was hacked.
That's okay, no worries. So I suppose those things happen.
You wouldn't believe, but you wouldn't believe how many systems are hacked. We just on SSH on our servers, we receive just like hacks attempts of hack, like thousands every day. How do you track such CVEs? Well, that's the question. How do we track such CVEs? So we do our own ingestion, so specific. So you can use, for example, so a commercial solution has its own system. For example, we ourselves, we daily ingest all the vulnerabilities on 26 different sources every day, automatically. We don't believe in humans, we believe in algorithms. So, so we don't even have the money to pay all these people, you know, putting things into it. So we have algorithms do that for us. I think at the moment we have like 26,000 vulnerabilities for open source components in our database. And you know, the competitors do similar things. And of course we do have there are open source solutions like dependency check from OWASP is a possibility. The problem with dependency check, it has a very restricted database. It doesn't support a lot of languages. And sometimes because of the mechanism it uses to identify components, it may be really a little bit fluffy about, it can give you a lot of false positive. But it's a great tool, don't get me wrong. It's just not good enough in my view. Why Ethereum will be better than Snyk? Oops. Well, I didn't want this to put into a commercial debate. Snyk is a great product, and I like it very much. They have a lot of money, so I'm sure they will produce. They do a great job. They also cover other aspects of the security. For the SCA specifically, well, we are more precise than them, and we have a bigger vulnerability database. I don't want to go into the details. Please ask me privately. I just don't want to. But they have a great product. So if you're already using Snyk, there is no need to change it. I think it's a really good product. Have you found any WAF product where that protection against this sort of issue? Did we find any web application framework that are able to protect us against these issues? No. Well, I found one that was able to detect OGNL, but I don't remember which one it was. But so far I didn't find. I find maybe another one that was looking at base 64, but was just giving out some random warnings, and the people switched it off. So the problem is that you have to be, you have to be really precise. You don't want to stop legitimate traffic. So maybe a more like a bot protection system is more efficient, because usually those calls are not coming from real servers, are coming from bots. So a bot protection system will be better than a web application framework in this specific case. What is your view on ethical hackers reporting issue to you? It's good. No. Should you engage with them, or a slippery slope like someone finding your wallet by the system with you? No. I'm perfectly in favor of having people reporting things to open source. We try to do it when we find something. We routinely assess open source project. When we find something, we report them. We don't do ethical hacking, but of course, everybody doing ethical hacking should be compensated, or at least celebrated for what they do, because it's great. Dependabot uses the GitHub database. So we're back on this. Where it was this. So Dependabot uses the GitHub database. So that's a problem with Dependabot. And also, it's not again, the precision that it has is limited, because a commercial SCA tool will create your dependency graph, because it's not only the first component that you're using. That component could be using another component, could be using another component. So you have to develop the entire dependency graph. So a commercial solution will do that. Dependabot not always do that, especially with Java and .NET. It doesn't happen really. Can you put the list? Is it reasonable to limit the vulnerability checking to software which is visible to the internet, or you have to check everything? In security, is all about prioritizing. You never have time. So the problem, you never have time. You have to prioritize what you do. Any person in security listening to me right now will know that. You have to prioritize. And yes, absolutely, prioritize first the software which is visible to the internet. Do not start necessarily checking everything unless you have the power to do so. Of course, if you have the power, yes, by all means. But most times, or many times, you don't have such power, and you have to prioritize. For example, in our system, there is an inside view that tells you across all the projects you scanned what is the most offending vulnerable component. And of course, you want to start fixing that one, not all the others. Can you post the GitHub link in chat? Yes, of course. Sorry. Sorry. No, I'm not finding myself. Again, other things I prepared, I don't have it anymore. Give me a second to do a Google search. Here we go. This is the GitHub advisories database. You can have a look at that. And there are also the totals. Oh, they put the totals. That's nice. So you have also the totals now. NPM, Java. Oh my God, 755. No, that's not really good. Sorry, I put it here. Yeah. So this is the database we're talking about. So as you can see here, as you can see here, you have the single ecosystem by ecosystem. They recently added Go 155, really below par. There are at least 800 of vulnerabilities, or probably 600 and 400 in the NVD itself. Maven, no. NPM is more like it, but we're still like 6,000 below normal. They will get there. So they're doing a great job. What I'm saying is not good enough at the moment. You should do something else. At least pair it with an open source solution, something else. Okay, no more questions, I think.
I think that's it. Thank you very much, everybody. And thank you, Bruno, for an amazing presentation. I believe the video will be available within the next couple of weeks. So check out the LJC website. And thank you very much for attending. See you later. Bye.